All right, so question 2 on the practice midterm says, given the Rodriguez formula, which we write down as, write down this as P sub L of x is equal to 1 over 2L L factorial d by dx to the power of L, x squared minus 1 to the power of L. So given the Rodriguez formula, we want to find, for part A, we want to find P3 of x. So in this case, we're just going to sub L is equal to 3 into the Rodriguez formula because, of course, we're looking for P3. So we do this, and we get P3 of x is 1 over 2 to the 3 factorial d by dx cubed x squared minus 1 to the power of 3. So if I were doing this midterm, I would probably start with this question just because it's, for me, the most mathematically simple. It's just a couple derivatives and then an integral for part B. But when I enter a test, I kind of look through all the questions briefly and at the very start, and the ones that I know how to do and the ones that I know that I will do well on, I tend to do those ones first, just because in that case, if I run out of time, at least I know that I've tackled the ones that I know how to do. So plugging this through, we go P3 of x is simply 1 over 2 to the power of 3 is 8, and 3 factorial is 6, so right away I can say this is 1 over 48, d by dx cubed. And what I'm going to do is I'm going to expand this x squared minus 1 into its 3 parts. This might make the derivative a little bit easier rather than getting into some chain rules. So I can go through one more step and expand these, and we'll get the third derivative. So dx by d3. It's the same notation. It's the derivative 3 times applied. And we're going to get x to the 4 minus 2x squared plus 1 times x squared minus 1. Just expanding these two together. And I do one more time. Third derivative with respect to x of x to the 6, and then I'm going to say minus 3x to the 4 plus 3x squared minus 1. Now I just have to do this derivative, so come up here, draw a line down the middle. We have 1 over 48, and the third derivative of x to the 6, so I'm just going to do them in steps so that we don't miss anything. I'll erase this. We have the second derivative. It's going to be 6x to the 5 minus 12x cubed plus 6x. And the last one is just 0 because it's constant. 1 over 48 d by dx of 30x minus 36x squared plus 6. And one last derivative, sorry, x to the 4 here. 1 over 48, and the last derivative 3 gives us 120x minus 72, sorry, x cubed minus 72x plus 0. And there's a common factor here, and that's 24. If I pull that out, you can check that at home, but 24 is a common factor between these. So you get 1 over 2, 5x cubed minus 3x, and our final answer for P3 of x is going to be 5 over 2 x cubed minus 3x over 2. So once again, to kind of walk through like I did on the last practice midterm videos, I start with the Rodriguez formula, which is given to you in question 2. That's what Jason gives you to start with, and you want to find P3 for part A, which means that we're just looking for the L is equal to 3 term. Plug that in, and we have simply a derivative that we have to take. So it's just math from here on out. We have the derivative 3 times of x squared minus 1 cubed. I chose to expand it first because I figured that taking a derivative of a polynomial in this form is easier than doing the chain rule a couple times with the 1 over 48 out front from the constants. Work through the derivatives, and you end up with 5x cubed over 2 minus 3x over 2. In this case, we're using P3 of x, but remember that when we're talking about the separated solutions to the Laplace's equation, in the theta coordinates, we're going to substitute x is equal to cosine theta, and those are the Legendre polynomials, which we talked about in class. So in part A, we found that P3 of x was equal to 5 over 2 x cubed minus 3x over 2. In part B, it asks to prove or to show that P3 of x is orthogonal to P0 of x. So P0 of x and P3 of x are orthogonal. Right away, we can say that P0 of x is equal to 1, but if you haven't quite memorized that yet or can't quite see it from the formula, we can quickly plug it in. We have 1 over 2 to the 0 0 factorial d by dx. So the 0th derivative, which means we take no derivative to the 0, is just going to be 1 over 2 to the 0 is 0 factorial is also 1 times 1 because the 0th derivative doesn't happen. And then x squared minus 1 to the power of 0 is also 1, so we have a bunch of 1s all multiplied together, and this is equal to 1. So p3 of x is 5 over 2 x cubed minus 3x over 2, and p0 of x is just equal to 0. Now, to remember, if you remember how to prove that the PLs of x's are orthogonal, we take the integral over the bounds, which here we're saying the bounds are from -1 to 1, and we'll have PL of x multiplied by PL prime of x times dx. And now what this notation means is that we have one PL of x, so one function of x given from the Rodriguez formula, multiplied by a secondary one with a different value of L. Or we can also say it's the same value of L, but we'll see that if it's a different value of L, they're always going to be equal to 0. So this is going to be equal to 0 if L does not equal L prime. So when L and L prime are different, this is equal to 0. And otherwise, we're going to get the formula 2 over 2L plus 1 when L is equal to L prime. So if we have P3 times P3, then we can figure out what this integral is given this here. Otherwise, it's going to be equal to 0. So that's what the general form of orthogonality of these Legendre polynomials says from the Rodriguez formula. Here we have to show that. So what we can do is we just take the integral. So you have -1 to 1, and we have P3 of x multiplied by P0 of x dx. We want to show that this is equal to 0 by working through the steps. So if we just plug these in, we end up with, from -1 to 1, 5 over 2 x cubed minus 3 over 2 times x times 1 dx. And this integral is just equal to, let's use my notes so I don't make a mistake, we have 5 over 8 x to the 4 minus 3x squared over 4, evaluate between -1 and 1. And right away we can see that because this is an even function, and we put the 1 in here, it's going to expand out and give us just a positive 1. The -1, same thing, and the derivative is taken over the bounds. So if we do this, we have 5/8 minus 3/4 minus 5/8 minus 3/4, which is just equal to 0. So again, to walk through the steps here, we want to show that P3 and P0 are orthogonal. P0 is just found by plugging 0 in for L. It's just equal to 1, so that's a really easy Legendre polynomial to remember. Then we want to take the integral from -1 to 1, because those are the bounds that Jason gives, of P3 times P0. And this integral, when we work it through, we're going to find that it's equal to 0, which is what we should expect given the general formula for orthogonality of the Legendre polynomials, which says that when we take the integral from -1 to 1 over one Legendre polynomial evaluated at one value of L multiplied by a secondary Legendre polynomial evaluated at a secondary value of L, L prime, this is equal to 0 if L is not equal to L prime, and it's equal to 2 over 2L plus 1 if L is equal to L prime. And this is just a constant of normalization, which comes from the integral. So you can, this is in the textbook and kind of in the notes online as well, but if he's asking you for orthogonality, it's just, you have to remember that this integral here should be equal to 0, and you just have to show that through some steps in integration.